Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics. This is the extended physics, and today we have set our hearts to solve May-June 2022 2 paper. This paper 2 belongs from the Zone 2. This paper 2 is about multiple choice questions. The total time allowed for this paper is 45 minutes. Total marks for this paper are 40 marks. The value of the G in this paper we will be taking as 10 Newton per kg, or you can say 10 meter per second square. But in your recent papers from the 2023 and onwards, the value of the G will be taken as 9.8 Newton per kg or 9.8 meter per second square. So without further ado, let's start today's paper. So here we have this paper, May-June 2022, and it's paper 2-2. So the first question is coming up on your screen. So the question number 1 is very small values of which quantity are measured using a micrometer screw gauge. You see, the micrometer screw gauge you use to measure the distance, the length. It is not used to measure time. It's not used to measure pressure. It is not used to measure momentum. It is used to measure the distance. So I think question number 1, D is the answer, sir. D is the right answer. Okay. So then we have question number 2 on your screen. A man stands next to a railway track. The train traveling at 40 meters per second takes 2 seconds to pass the man. What is the length of the train? Very simple. Length is equals to speed multiply time. So the length is equals to speed multiply time. So 40 meters per second multiply 2 seconds, that will be 80 meters. So the length of the train is 80 meters. So we think D is the choice. Question number 2, D is the right answer. Question number 3 showing up on your screen. He says, which quantity is equals to the acceleration? Acceleration is if you have a speed time graph, the gradient of the speed time graph will be the acceleration. Gradient of the speed time graph. The gradient of the distance time graph is speed, and the area under the speed time graph is equal to the distance traveled. So what is acceleration? Acceleration is the gradient of the speed time graph. So question number 3, D is the choice. On the moon, all objects fall with the same acceleration. Which statement explains this? You see, the on the moon, all the objects have the same weight. That is wrong. Different objects, obviously, according to their mass, will have different weight. The moon has a smaller gravitational field strength than the Earth. That is true, but it has nothing to do with why the falling objects will have the same acceleration. The weight of an object is directly proportional to its mass. This is true. This is the reason. The weight of an object is inversely proportional to its mass. W is equals to mg. G is a constant, so W is directly proportional to mass. C is the right statement, sir. Question number 4, C is the right. A measuring cylinder contains 30 centimeter cube of a liquid. Some more of the liquid is added until the liquid level reaches the 50 centimeter cube mark. The reading on the balance increases by 30 gram. What is the density of the liquid? So the volume of the water you added, that will be 50 minus 30 centimeter cube, and it will be 20 centimeter cube. So the volume of the water you added is 20 centimeter cube. The volume of the water you added is 30 grams. So its density will be mass divided by volume. So 30 gram divided by 20 centimeter cube, and it will be 1.5 grams per centimeter cube. 1.5 grams per centimeter cube. I think C is the choice. Question number 5. Question number 6. An object moves at constant speed around a circular path. Which statement is correct? You see, whenever you move in a circular path, your direction has to be changed every moment. So there is a resultant force acting on the body. Its direction, the direction of the resultant force is always towards the center of that circle in which that body is moving. There is also an acceleration. Acceleration is also always directed towards the center of the circle. So I think C is the right choice, sir. A resultant force acts on the object towards the center of the circle. Question number 6. A beam is pivoted to one end as shown. The beam weighs 6 Newton and its weight acts at a point x 40 centimeter from the pivot. A force of 4 Newton is applied to the beam, causing it to balance horizontally. In which direction and where is 4 Newton force applied? So you see here we have the pivot, here we have the center of gravity of that balance and that beam. So it's 40 centimeter here. So here on this side, it is also 40 centimeter. So it is trying to produce a clockwise moment. To balance it, I need an anti-clockwise moment. So I have to apply a force in the upward direction. And because that force is 4 Newton, that force is less than the weight of this beam. So the moment arm should be larger. So this will be on the right side. The force will be applied on the right side of the X. So let me suppose that this is its moment arm is D. So if the moment arm is D from the pivot, then I can find out the clockwise moment will be equal to the anti-clockwise moment. So 6 Newton multiplied 40 centimeter will be equals to 4 Newton multiplied D. D is the moment arm of this force. So the D will be equals to 240 divided by 4 and the D will be 60 centimeter. So if this distance is 60, this is 40. So this distance will be 20. So the force F, which is of 4 Newton, will be applied 20 centimeter to the right of the X in upward direction. So what is the answer? Vertically upward at 20 centimeter to the right of the X. So I think D is the choice. Question number 7. D. Question number 8, the diagram shows two forces acting at right angle to each other. What is the resultant of the two forces? You see these two forces are acting perpendicular to each other. So I can apply here, the tails are joined together. I can apply the parallelogram law, or I can also apply the triangular law. Here I'm showing you how to apply the parallelogram law because the two tails are joined. So I will complete the parallelogram. Where the tails are joined, you join it with the opposite corner of the parallelogram. That is your resultant. If this is 3 Newton, this is also 3 Newton, this is 4 Newton. If this angle is 90, this angle is 90. If you look at this triangle, it's a right angle triangle. If you will apply Pythagoras, you will be able to find out the resultant. So r square is equals to 4 square plus 3 square. So r square is equals to 16 plus 9. R square is equals to 25. So take square root on both the sides. So r will be equals to 5 Newton. So the resultant will be 5 Newton. So I think B is the choice. Question number 9, which statement describes the impulse acting on an object? Whenever impulse is basically when there is a change in the momentum. The change in the momentum is equals to the impulse. That's the definition of impulse. Or the impulse is also force multiplied the time. Impulse is the change in the kinetic energy of the object. No, impulse is the change in the kinetic energy is equals to the work done. Impulse is the change in the momentum of the object. Then this is the right statement, sir. Okay. Impulse is the rate of change of force acting on the object. No, impulse is the rate of change of momentum of the object. Rate of change of the momentum is known as force. Impulse is the change in the momentum. Question number 9, B is the choice. Question 10. A ball of mass 0.16 kg is moving towards at a speed of 0.50 meter per second. Sorry, a ball of mass 0.16 kg is moving forward at a speed of 0.50 meter per second. A second ball of mass 0.10 kg is stationary. Its velocity is zero. It is at rest. The first ball strikes the second ball. The second ball moves forwards at a speed of 0.50 meter per second. What is the speed of the first ball after the collision? See, the the momentum before the collision of the system is equal to the momentum after the collision. So m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2. So m1 u1 plus m2 u2, the momentum before the collision, is equals to m1 v1 plus m2 v2, momentum after the collision. So 0.16 multiplies 0.50 plus 0.1 multiplies 0 is equals to 0.16 multiply v plus 0.1 multiplies 0.50. So it will be 0.08 plus 0 is equal to 0.16 v plus 0.05. So 0.16 V will be equal to 0.08 minus 0.05. 0.16 V will be equal to 0.03. So V will be equal to 0.03 divided by 0.16, and that will be 0.1875, which is approximately 0.19 meter per second. 0.19 meter per second. So I think B is the choice. Question number 10. Question number 11. He says the tennis ball is dropped from the position 1. It falls vertically onto a hard surface at the position number 2. So if you look at the position number 2, it has touched the ground. All its gravitational potential energy has been converted into kinetic energy when it's coming down. And here the ball has squeezed a little bit, which means it also has now the elastic energy. So there he says which energy changes have taken place between the position 1 and the position 2. At the position 1, it has gravitational potential energy. As it falls, its gravitational potential energy converts into the kinetic energy. When it touches the ground, its kinetic energy, before that, its kinetic energy becomes maximum, gravitational potential energy becomes zero, and some of its, when it touches the ground, some of its kinetic energy is converted into the elastic energy. So, which energy changes have taken place between the position 1 and position 2? The gravitational potential energy converted into the kinetic energy converted into the elastic or the strain. So, I think B is the choice, sir, without any doubt. Question number 12. A boy holds onto a bar and pulls himself up until his chin is level with the bar. He raises himself to 40 centimeters in 0.5 seconds. The weight of the boy is 500 Newton. What is the average power he produces as he raises himself? You see, the work done is equal to the weight multiplied the height gained, but the height must be taken in meter. Once you know the work done, then we can find the power. The power is equal to the work done divided by the time. So this is the strategy, how this should be done. This is question number 12. So the work done is equal to the gain in the gravitational potential energy. So that is equal to the weight multiply height. So 500 multiply 40 divided by 100. I converted that centimeter thing into the meter. So 200 joule work is done. Power is equal to the work done divided by the time. So 200 joules divided by 0.5 seconds, and that is 400 watt. So the power is 400 watt. The power is 400 watt. So I think B is the choice. Question number 13. The diagram shows a deep reservoir formed by a dam. On what does the pressure of the X depends? You know, the pressure of the gas, of the liquid, sorry, is equals to, the formula is rho, and then we have the G, and then we have H. Here the rho is the density, so the pressure depends upon the density of the liquid. G is the gravitational field strength. So the pressure of the liquid depends upon this, and H is the depth of the liquid above the point of observation. So on what does the pressure at the X depends? The depth of the water at the X. Yes. The length of the reservoir, no. The surface area of the water, no. The thickness of the wall, dam wall, no. A is the choice. Let's check. Yeah. Question number 14. The conditions of a sample of gas change in two stages. Stage number 1, increase the temperature at constant volume. And stage number 2 is increase of volume with no further change of the temperature. Which row about the pressure after each stage is correct? You see in the stage 1, when you increase the temperature of a constant volume, and the volume is constant, then the pressure and the temperature, they are directly proportional to each other. If you will increase the temperature, the pressure will increase. So this is for the stage 1. So either it is C or it is D. Then in the stage 2, he says increase of the volume with no further change of the temperature, where the temperature is kept constant. If you will increase the volume, the pressure of the gas will decrease. Increase, decrease. In stage 2, the pressure will decrease. So C is the choice. Question number 15. Small pollen particles are suspended in the water. When viewed with a microscope, the pollen particles can be seen to be moving with the about irregularly. What causes this movement? You see the pollen grains are bombarded from all the sides by the water molecules. So water molecules are moving randomly when they bombard the pollen grain, and what happens? The pollen grain also perform random motion. So you see the pollen grain size is large, the size of the water particle is very, very, very small. The pollen particles are being bombarded by the lighter particles of the water, that is true. The pollen particles are being bombarded by the heavier, no. The pollen grains are heavier and the water molecules are not that heavy. So I think B is the choice. This is the exact sentence. The temperature is not different. Okay. So question 15, B is the choice. Yeah. Question number 16. Question number 15, B was the choice. Question number 16. The diagram shows a liquid in glass thermometer. Which physical property of the thermometer used to measure temperature? You see in this thermometer, for example, the thermometer has a liquid in it. For example, it's mercury. And when the temperature, for example, changes, the expansion in the mercury also changes. So the expansion of the liquid in this case is an indicator for the temperature. So more the expansion, the more is the temperature. Less the expansion, the less is the temperature. So expansion of the liquid is used to measure. That's the thermometric property. So question 16, B is the choice. Yes. Question number 17. A block of lead of mass 500 gram is at its melting point. The specific latent heat of fusion of the lead is 23 kilojoule per kg. How much energy is required to completely melt the block? You know, the heat is equals to ml. The heat is equals to ml. And the mass is given, the L is also given, but the unit of the L is 23,000 joules per kg. So that's why the M will also be taken in the kg, because the units of the mass must be consistent in both these quantities. So 500 divided by 1,000 kg, so multiply 23,000. So you will have 11,500 joules. When you round it off, it is 12,000 joules. 12,000 joules, 12,000 joules. So I think B is the choice. Question number 17, B is the choice. Yes, sir. Question number 18, a glass contains an iced drink on a warm day and humid day. Water starts to form on the outside of the glass. What is the name of the effect? by which the water form. You see, when the water in the glass is cold, so there is humidity in the air. So air has water vapors. I mean, the water in the gaseous form. What happens when they touch this cold surface of the glass? Their condensation takes place. So that gaseous water converts into the liquid. That's why you will have water outside that glass. So this is condensation. A choice, question number 18, A choice. Yes, sir. One day, one end of a copper bar is heated to a high temperature. Which mechanism is responsible for the transfer of thermal energy to the other end of the copper bar? You see, copper metal is solid. So by the conduction, the heat is transferred from the hot end of the copper to the cold end of the copper. And in the conduction, sorry, I said conduction, and by the conduction, the heat is transferred to the copper, and this happens, the energy is transferred by the vibration of the water particles on its lattice, and the copper also has free electrons, so the diffusion of the free electrons takes place, means that the electrons at the hot end absorb thermal energy, and they go to the cold end, and they collide with the molecules there, and in this way they transfer the energy from the hot end to the cold end. So the lattice vibrations of the copper ions and the movement of the high energy electrons along the bar. This is the best statement. The rest of the statements are not right. The molecules do not move. They remain in their fixed position. They only vibrate. So I think 19B is the choice. Yeah. Question number 20. 4 cubic copper containers are filled with water. The surfaces of all the containers are painted black. Two of the containers have sides of length 20 centimeter, and the other two containers have the sides of the length 40 centimeter. Two of the containers contain water at 80 degrees centigrade, and other two contain water at 30 degrees centigrade. Which container radiates energy at the lowest rate? You see, the lowest rate will be there where the temperature difference between the body and the surrounding is less, and the surface area is also smaller. So 30 and the room temperature, the difference between 30 and the room temperature will be less as compared to the temperature difference between the 80 and the room temperature, and the surface area here is smaller. So here the the container radiates energy at the lowest rate. A choice, I think. Question number 20. A is the choice, sir. The diagram shows a wave. You see, this is the amplitude. Amplitude is that from the mean position, how high you went. So the amplitude here is how much? It is 1 centimeter. And the wavelength here is from this point to this point. Sorry. This point. So this is one wavelength. Okay. This is one. And this is 8 centimeter. You see, this is a displacement and distance graph. On the y-axis, we have displacement. On the x-axis, we have distance. So from this graph, very easily, you can tell the amplitude. Amplitude is from the mean position, how high you went, or from the mean position, how low you go. And you can tell wavelength from here. On the x-axis, we have the wavelength. So the distance between the two consecutive points who are in the same phase, that is called the wavelength. So the wavelength here is 8 centimeter, and the amplitude here is 1 centimeter. So the amplitude of the wave is 1 centimeter, and the wavelength of the wave is 8 centimeter. So I think B is the choice. Yeah. He says the water wave shown, question number 22, water wave shown has a frequency of 4 hertz. What is the speed of the wave? We know the amplitude here, that is not the amplitude. This is the double of the amplitude. And here we have how many waves? 1, 2, 3. So three waves are in 36 centimeters. So what is the wavelength? Wavelength will be 36 centimeter divided by 3. And we know the frequency. Once I know the wavelength and the frequency, we can calculate the speed. Wavelength will be equal to 36 centimeter divided by 3, and that is 12 centimeter. The frequency is given, that is 4 hertz. So V is equals to F lambda. So 4 into 12, that is 48 centimeter per second. So the speed of the wave is 48 centimeter per second. Because the wavelength was in centimeter, that's why the speed is also in centimeter per second. Yeah. So C is the choice, question number 22. Yes, sir. Okay, here we have a question. He says a student uses one eye to look at the images in a plane mirror. Objects are placed on the line X and Y. Which objects give rise to image that can be seen by the eye at the E? Okay, so let me show you. I have done this. Okay, so this is question number 23. This is how we do this. For example, I take point R, I make a line straight on the mirror. This makes 90-degree angle with the mirror. Then I check how much is the distance of the R and the perpendicular distance from the mirror. I go same distance backward and I join that point with the I. Then I join this R with this point where this line cuts the mirror, and so this is the R prime. Same I do with the S. I take perpendicular line from S to the mirror. The distance of S and the mirror, same distance I go behind the mirror. Then I join this point with the I. When it cuts the mirror here, I join it with the S. So from here, the light has been reflected because these 2 points are on the mirror from where these rays have reflected. So that means R and S, they both can be seen by the eye. Okay. The same thing I do with the Q. I take it till this point, which is here, if you can prolong the mirror. And I go the same distance behind the mirror. And then I join it with the I. When it cuts the mirror at this point, I join Q with this point, and same I do with the T. I draw a line and I check how much is this distance. Then I go behind it, behind the mirror, same distance. At- And at this T prime, I join it with the I. And when it cuts this mirror, I join it with the T. So because these 2 points are on the mirror, so that means the E can see Q and the T. If you try to do with the P, then you will not be. If you join this point with the I, this line will be not intersect the mirror. So that means P and the P and the U, sorry, the man cannot see in the same way. X and the Y he cannot see. So the man the observer which is at E will be able to see R, Q, S, and T. Q, R, S, T. B is the choice. B is the choice. Question number 23. B is the choice. Question number 24. An object is placed in front of a converging lens of the focal length 15 centimeter. Which row describes the image of the object? Distance of the object from the lens. If you will take the distance, if you keep the distance of the object more than 15 centimeter from the lens, a real image will be formed. And if the distance of the object from the converging lens is less than 15 centimeter, then the virtual, it will be acting like a magnifying glass. Then the uh, virtual, upright, and magnified, or you can say enlarged image will be visible. If the distance of the object from the lens is less than its focal length, then the image formed is virtual, upright, and enlarged. So I think D is the choice. Question number 24. D is the right choice. Real, upright. When the image is real, it is not upright. Okay. When the distance of the object is more than the focal length, the image is not virtual. When the distance is more than the focal length, the image is real. It's inverted, but he says it's diminished. It is less than, the distance is less than 2f. When the object is between the f and the 2f, the image formed is enlarged. It's not diminished. So very conceptual question. D is the choice. Let's check. Question number 24. D is the choice. Yes, sir. Question number 25. The speed of light in the air is 3 × 8 meters per second. The critical angle for the light in a transparent plastic material placed in air is 37 degrees. What is the speed of the light in the plastic material? You know the critical angle here. So you know the refractive index N is equals to 1 by sine C. So it will be 1 by sine 37, and that is 1.66. You know the refractive index is also speed of the light in the air divided by the speed of the light in that medium, which is plastic here. So 1.66 is equals to 3 × 8 meters per second divided by the speed of light in the plastic is question. So let me call it V. So V will be equals to 3 × 8 meters per second divided by 1.66, and that is 1.8 × 8 meters per second. 1.8 × 8 meters per second. So that is question A option. Question number 25. A is the right option. Question number 26. He says, which type of waves are produced by a television remote controller? You see, the television remote controller use infrared waves. It's a famous fact. So question number 26, A is the choice. Yes, sir. Which statement correctly compares radio waves and the X-rays? The radio waves and the X-rays. Okay. So you remember this Ronald McDonald is very ugly except Gary. So as you go down, what will happen with the wavelength? Wavelength decrease. Okay, the wavelength will be decreasing. So they are talking about the radio waves and the X-rays. So the radio waves has longer wavelength as compared to the X-rays. And you know, all of these waves, all of these electromagnetic waves, they all travel with the speed of the light in the vacuum. So the radio waves have a longer wavelength as compared to the X-rays and the same speed in a vacuum. It's a famous fact. This is the character. These are the two characteristics of the. This is the characteristic of the electromagnetic waves. Question number 27, B is the right choice. Question number 28, the diagram shows the magnetic field around the three objects P, Q, and R placed close to each other. Which row shows the nature of each of the objects? Okay. So because the magnetic lines are entering here, so this will be the south and this will be the north. From here, the magnetic lines are going out, so this is north. This is the south. So here they have not shown any kind of polarity. So that cannot be iron because iron do magnetic induction, which means when you place a piece of iron near a magnet, it automatically the north and south pole is also developed on the iron. So it must be copper. So I think B is the choice. See, north, south, north, south, south, north, copper rod. I think uh, question number 28, B is the choice. Yes, sir, that's right. Hope you understand. There are no poles shown on the Q, so that must be copper. Copper is not a magnetic material, remember. Question number 29. A negatively charged rod is brought near to an uncharged metal sphere that is placed on an insulating stand. Which diagram shows the distribution of the charges on the sphere? So this end will become positive and this end will become negative. So it looks B is the right option, sir. Question number 29. B is the right choice. Question number 30 we have. A reservoir has a potential difference, a resistor has a potential difference of 12 volt across it and a current of 0.60 ampere in it. What is the resistance of the resistor? Very simple. V is equals to IR. V is equals to IR, so R will be equals to V by I. So 12 volt divided by 0.60 ampere, so that is 20 ohm. 20 ohm, D is the choice. Question number 30. Yes. Question number 31. He says there is a current I in a resistor of resistance R for a time T. The potential difference across the resistor is V. Which equation gives the power dissipated in the resistor? So, you know the power, there are three formulae for the power. Power is equals to I V, which is here. So this can be the answer. Power is also equals to very famous formula which you use in the answers of the transformer, I square R. And another very famous formula for the power is V square by R. So C is the choice. These are the three different formulae for power. Power is equal to IV, power is equal to I square R, power is equal to V square by R. So the correct formula given is this one. Power is equal to IV. Question number 31. C is the choice. Yeah, C is the choice. Question number 32. The four circuits shown each contain four diodes. In which circuit is the direction of the current in the resistor always from the red terminal to the black terminal? Let me show you. I'm just going to draw on the right diagram. Okay, so I'm going to use red color. For example, when the current flows from here, it goes in this direction. When it comes here, this diode is backward biased, so the current will go in this direction. Then this diode will be backward biased, so the current will go in this direction. And now the current will go in this direction. And then the current will go in this direction. Then the current can go in this direction. But from here, because here the voltage is higher, so current will not go in this path. Not in this path, but the current will go here. It cannot go in this path because here the voltage is higher. Current always go from high voltage to, from here, the current will go back. Okay. Now you see, when the current flows in this way, in this resistor, the current is flowing from the red terminal to the black terminal. Okay. Now you see when the direction of the, because this is alternating current, let me change the color. Now the current will flow in this direction from this side. The current will go in this direction. Now the current will go, when it will come here, this diode will be backward biased, so the current will go in this direction. So when it reaches here, this is backward biased, so the current will go in this direction. And the current will come here. Then the current will go in this way. So here, when the current comes here, it cannot go in this way because here the voltage is higher for the green. So the current will go in this way, and from there the current will go this way and this way. Or look at these green arrows and red arrows. In both the cases, whether the current came from this way or the current came this way, in both the cases, in the resistor, the current is flowing from the red terminal to the black terminal. So this is a famous diagram. This circuit is very, very famous. This circuit is for the rectification, full wave rectification of the alternating current. It's a famous diagram. For the Cambridge O levels, this topic has been taken out from the 2023. There's no more in your exam for Cambridge O level students. Okay, so 32A is the choice. Yeah. The question number 33. He says the diagram shows a battery connected to a potential divider and two lamps P and Q. The slider on the potential divider is moved from the end X to the end Y of the resistor. Which row shows the effect on the brightness of each lamp? Okay. So the voltage which is given to the P, that will not change because it's parallel to the battery. So it's always having that voltage. So its brightness should remain unchanged. It does not, it is not affected by the voltage drop across the Q, because P itself is parallel to the battery. So to always get the same voltage, the voltage equals to the EMF of the battery. So the brightness of the Q as you go from X to Y, this resistance, as you go from X to Y, so what will happen? The current flowing through the Q, so you see, try to understand. So here you have Q. If this slider will be going towards the Y, then the resistance, which is in series with the Q, will be gradually decreasing. So this whole branch will be getting the voltage equals to the EMF. So if this resistance decreases, then the Q will be getting more and more voltage. So that Q will be becoming more and more brighter as you will be moving towards the Y, because this resistance which will be in use, that will be gradually decreasing when this slider will come here. Only this resistance will be used. This portion of the resistance will be used. So the voltage drop on this will be less, and the voltage drop on the Q will be gradually become more. So it will become more brighter. So I think C is the choice, that the P remains unchanged and the Q becomes brighter as this slider moves towards the Y. And the reason is this portion of the resistor which is being used is becoming smaller and smaller. So the voltage drop at the Q will increase. So it will become more brighter. So we think question number 33, C is the choice, sir. Yeah. He says, what is the truth table for the logic gate shown by the symbol? Okay. So this is AND gate, and then this circle means NOT gate. Okay. So we can make the truth table for this. The truth table for the AND gate, AND is like multiplication, and NOT gate is the you invert it. Okay. So 0 0 0 1 1 0 1 1. 0 multiplied 0 is 0. So when you invert it, it is 1. 0 multiplied 1 is 0. When you invert it, the answer is 1. 1 multiplied 0 is 0. So when you invert it, it becomes 1. 1 multiplied 1 is 1. When you invert it, it's 0. So what's the choice? So I say, let me show you. 1 1 1 0. Okay. 1 1 1 0. So this is that truth table. So D is the right truth table. Question number 34. D is the right truth table. So our answer is right. You see, this is the truth table which I made. This is AND gate and then a NOT gate. He says, question number 35, a coil XY is wound around a cardboard tube. When the south pole of a magnet is pushed into the coil XY, the galvanometer deflects to the left. It deflects to the left, okay. What other movement of the magnet will produce a deflection to the left? Okay. So you see this south pole is approaching. So to stop this approaching south pole, here a south pole will be, and here you will have automatically north. Okay, so now we will look at these four situations and we will decide in which you will have this same poles on this this coil. Okay, here the south pole is going away, so automatically, okay, to stop this south pole going away, here you will have the north and here you will have the south. So this is not matching with that situation. Here a north pole is going away from the right end. To stop it, a south pole will be formed here. Automatically a north pole will be here. So this is also not matching with this. Here a north pole is approaching. To stop this north pole approaching, you have to have a north here and a south automatically will be here. So this is also not matching with this. Here you have a south pole from the right and going away. To stop it, automatically a north pole will be induced here and a south pole will be induced here. So from here, I can tell you the direction of the current induced in the D will be the same. Okay, so I think D is the choice. Here the galvanometer will show also again the deflection to the left. So D is the choice, sir. Question number 35, very tricky question. Question number 35, D is the right answer. Okay. Question number 36. So in the question number 36, it says which transformer can change a 240 volt AC input into a 15 volt AC output? Okay. So we are looking for a step down transformer. So the ratio of the voltages is equal to the ratio of the turns. So Vs by Vp is equal to Ns by Np. Let me show you. So Vs by Vp is equal to 15 by 240, that is 1 by 16 in the A portion, and the ratio between the number of turns on the secondary to the ratio to the number of turns in the primary. So that will be 40 by 800, that will be 1 by 20. In the B, Ns by Np will be 25 by 1000, and that will be 1 by 40. In the C, Ns by Np will be equal to 15 divided by 2400, that will be 1 by 160. And then the D portion, Ns by Np, the number of turns in the secondary, ratio number of turns in the primary. So that will be 75 divided by 1200, and that will be 1 by 16. So in the D part, the ratio of the turns of the secondary to the turns in the primary is same as the ratio of the voltage in the secondary and voltage in the primary. So this is 1 by 16, this is 1 by 16. So D is the right option, sir. D is the right option. I hope you understand how I have done this. Question number 36, D is the option, sir. Yeah, that is right option, sir. Question number 37, the diagram shows a current carrying wire in a magnetic field. In which direction is the force acting on the wire? So this is a current carrying wire placed in the magnetic field. So we can apply the left hand rule. I will take my left hand rule. This is my left hand rule. And I will strike these three fingers mutually perpendicular to each other. You see, this is F, the force, this is the magnetic field, and this is the current. And the thumb is force, and this index finger is the magnetic field, and this middle finger represents the current. Okay, the magnetic field is going in this way, that the charges are going in this way. My thumb is pointing downward towards the bottom of the page. Okay, so I think towards the bottom of the page. Let's apply again. North pole is from north to south. Charges are going this way. My thumb is pointing downward towards the bottom of the page. Question number 37, A is the choice. We have used the left hand rule, Fleming's left hand rule. Okay. Question number 38. They say a scientist was asked to separate the following equations into two categories: nuclear fission and nuclear fusion. In nuclear fission, you see you have a larger nucleus and it breaks and converts into two smaller nuclei, and now neutrons are given out. In the nuclear fusion, two smaller nuclei come, join, make a larger nucleus. So you see, and the Fian. So this is Fian, and this is Fian. Why I'm saying Fian? Because here a larger nucleus breaks down into two smaller nuclei and neutrons are given out. Okay. So nuclear fusion, in the fusion, the two smaller nuclei join to make a larger nucleus. So 2 and 3 is fusion. So which equation shows nuclear fission? 1 and 4. 1 and 4. I think C. In the equation number 1 and 4, the fission is shown, whereas larger nucleus breaks into two smaller nuclei and neutrons are given out. So question number 38, C is the choice. Yes, sir. Question number 39. Which radioactive source is used in a smoke alarm system and what is the reason for this? In the smoke alarms, we always use that which that's radioactive isotope, which gives out alpha particles. And alpha particles are very ionizing and their penetration power is very low. So we use alpha particles because they can ionize the smoke. If the smoke is produced, that the it can ionize. Because we use alpha particle causes most ionization of the air. Yes, that is true. We do not use gamma rays. Gamma rays has very strong penetration power. So, for example, in our kitchen, let's say we have put a smoke alarm. So, if you use isotope which is giving out gamma rays, the gamma rays will reach the people who are working in that kitchen, and they will get sick. So, B is the choice, sir. Question number 39. B is the choice, sir. Then we have question number 40. A beam of alpha particles and beta particles is incident at right angle to an electric field. Which statement about the deflection of the particles in the field is correct? You see, alpha particles are positively charged. The alpha particles are positive, and the beta particles are negative. So, in electric field, they will be deflected in opposite directions. Alpha particles deflect, but beta particles do not deflect. No, no. Alpha particles deflect in the opposite direction to the beta particles. Yes, this is the right statement. Beta particles deflect, alpha particles do not deflect. That is wrong. Both alpha particles and beta particles deflect in the same direction. That is wrong. Because alpha and beta, they both have different charges on them. That's why in the electric field, they will be deflected in different directions. Okay. So the alpha particles and the beta particles will deflect in opposite direction. So B is the choice. Question number 40, B is the right choice. So, my dear students, in this video, we have presented you the solution of the May June 2022 2-2 paper, and I have tried my best to explain you the concepts and the procedures and how I have decided that which option is the correct option. But still, I'm a human being. Maybe I'm not explaining that much. Maybe I made some mistake. Please forgive that. And if you think this video is useful, if this video is helpful to you, please like this video. Please share the link of this video with your friends, with your class fellows, with your junior students, with your teachers, and also share the link of this video on your WhatsApp groups, on your Facebook, on your Twitter account, on your Snapchat, on your Instagram, on your Telegram, whatever social media you are using, on TikTok. Please share the link of these videos there. When you do this, you help me to promote my channel, and that is the support for me. So I'm really proud, and I think I'm blessed that I can make these videos, which can make the life of so many students around the globe a little easier, their parents' life little easier, and their teachers' life little easier. By sitting at their home, by just playing, watching the videos on the YouTube, they are able to practice and prepare their physics exam. So keep working hard, keep studying hard, keep watching my videos, keep sharing my videos. So may God bless you. Have a good day. Bye bye.